see A is taller than the rest, while B is the most flat curve. Okay? So the figures below show some examples of normal curves with different means and standard deviations. Okay? So the figure A shows a normal curve with a minimal standard deviation, while the B has a large standard deviation with a mid, and C has a median standard deviation. Though they seem to be different, they share common properties. Okay? Just as you can notice, A has a minimal standard, the minimal standard deviation, while B has a large standard deviation, because as we have discussed before, standard deviation stands for the measure of dispersion. So meaning the data here inside the B are dispersed. Okay, that's why it's so flat and it's so wide. Right? So since the normal curve depends on the mean and its standard deviation, there are many different types of normal curve. Okay? Not just these three. Though there are many different types, they have the same or common properties. So what are the properties of a normal distribution? First, the normal distribution is bell-shaped. So you can see here on the figure on the lower right, you can see the figure, it looks like a bell. Second, the median and mode are equal and located at the center. So here at the center, don't mind the values here on the lower part. We will discuss that later on. So the mean, median, and mode are all here in the center, or in simple say, the measure of central tendency are all here. So the normal distribution curve is unimodal. When we say unimodal, there's only one mode in this set of data, continuous data. The curve is symmetrical about the mean. When we say symmetrical, imagine you have a paper and then you fold it in the middle. Now, you open it again. So you can see you created a line wherein there are two equal parts. So meaning, if you fold it, both sides are kinda equal. They are symmetric on each other. Next, the curve is continuous. When you say continuous, it is continuing on both sides, going to the left and then going to the right. The curve is asymptotic with respect to x-axis. When we say asymptotic, it never touches. Okay? So imagine this line, the horizontal line here, is our x-axis. The normal curve will go very near on the x-axis, but it will never touch the x-axis on both sides. That is the definition of being asymptotic. Lastly, the total area under the normal distribution curve is equal to 1 or 100%, meaning the probability here inside is a total of 100%. Right? Same goes with the discrete random variable. When we add the column of p of x, the answer must be 100% or 1. Okay? Now, with that, the statisticians created this type of normal curve, and we call this standard normal curve. Okay? Since the appearance of the normal curve depends on the distribution's mean and standard deviation, there must be infinitely many different normal curves. In order to make use of its properties, statisticians or mathematicians came up with a way of transforming every normal curve to a standard normal distribution or standard normal curve. Okay? So a standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. Okay, remember that. When we talk about standard normal distribution, the mean is always 0 and the standard deviation is always 1. Basically, any normal distribution could be transformed into this type. So if you have a given normal curve, you can transform it into a standard normal curve. Okay? All you have to do is to follow the formula to do some certain steps. So the formula for the standard normal distribution is this. Okay, y is equals to, I'm not gonna discuss this anymore. Okay, so since we are not focused